because there are some functions which has a name. Let's suppose there are functions pandas. We are giving the variable name is pandas, then it will clash. Like the variable names are designed to indicate the intent and purpose of its use to the end user. So hence, it is better to avoid one character variable names. So one character variable names are usually used in iteration and functions and looping constructs. So go to the next slide, please. Yeah. So the variables can be named alpha numerically. So if I have tried called age, that age is a variable whose value is 55. Then I can either have the entire age in lowercase, or I can also begin with an uppercase. So you can also add a number to it. So let's say if I am creating another variable called age2, then I can add number after the alphabets, not before the alphabet. So one thing that you would have noticed here is that the first letter should always begin with the alphabet. But however, if you were to begin with a number, the compiler throws an error saying invalid syntax, as I did here in this slide, where I put the number 2 before the variable age, then it gives me an error. So you can try this in a Jupyter notebook. Now, giving the variable, let's suppose if you are giving the variable age and whatever the number you are assigned, let's suppose 55 or whatever. If you are assigning the number before the variable, then it will give you error. So always try to avoid these simple things which clash inside the Python.
I think let's start first with the software and we write some basic commands there, if you allow
Yeah,
me.
sure. Yeah, please. Okay, so write these things. Okay, so how they will say that how to assign a name to variable, because this is a simple mistake we usually do.
So this
All
is the software and we
yeah,
start the Python 3.0 like this.
yep. Okay, so assigning the variable now. So any variable and their number. So let's suppose, yeah, age, yep, 10.
There's a run button
Yep.
showing error.
So showing the error here because okay, so which so can you write the print in the parenthesis age inside the parenthesis age?
Here it is. Then
Yeah, because the Python version you are using it's 3.7, is it?
2.8.
3.8. In the Python 2 version 2, so you don't need to write any variable inside the parenthesis while using print command. But in 3.7 or 8, you have to write inside the parentheses. Now, when you assign the variable instead of age, you have to write 2, which is number, and then age, yes, in the second cell. Yeah, yeah, run it. Yeah, it gives you error. Why? The reason is that because you have not assigned the variable correctly, because you have assigned the number before the variable. So this is the mistake that I wanted to explain. Yeah, it will not give you error. So it doesn't matter either it is lowercase or uppercase of variable.
I can write like this.
Yeah, so you can print multiple.
There you go.
So this is assigning a name. So now what we learned how to assign name to a variable. So we always do the common mistake while assigning the name to variable.
Also, we can do.
Yeah. So these are all the operations that we will learn next slides. Okay, let's complete this. So go to the slide.
Go back to the slides.
Yes. Yeah. So the only other special character that is allowed while naming a variable is underscore. Now let's say if I want to create a variable that conveys the employee ID, then I can separate the employee and ID with an underscore. Now underscore is the only other special character that is allowed. Now, if you use any of the other special characters, you will get an error that says cannot assign to the operator. So, though underscore is allowed, it is better to not begin or end with an underscore, and that is common unaccepted naming convention, though it is accepted by the compiler. So if you begin or end with an underscore, you are not likely to get an error. So it is usually not a practice that is followed. So now you can start with underscore or employee underscore ID, whatever. Because employee underscore ID is equal to, yeah. Or you can, even you can start your variable with underscore or end your variable with underscore. So mean that, so you can, if you want to change your variable, yes, you can change with your variable with underscore. If you use another character, it will give you error. Why? Because these are inbuilt character or functions. So it means that underscore is not inbuilt character or function. And you can assign a variable to another variable too. It means the copy. Okay, let's go to the slides. So there are a few case types that is commonly accepted while naming variables. The first is camel case. It can be lower or upper. For example, you have here where age of the employees given with E in capital. Now, this is a lower camel case. So the example on the right is an example for the upper camel case. Now, in this example, the letter in age of the employee begins with a capital letter. So the next case type is the snake case where I am separating age and emp by an underscore. So an underscore can be used between two sets of letters or between two letters, and that is snake case. The letter after the underscore should always be in lowercase, but the first letter of the variable name can be lower or uppercase. So next uh, case type is Pascal. So where I am again going to take age M. Now where the first letter of the age is under this case and the first letter of the M is also under case. Now there are commonly used case types in Python. Now the compilers is not going to throw an error if you name the variable wrongly, but these are conventions that are in books and are accepted. However, there are other case types which use hyphen, but those case types will not be allowed in Python. So if you use a hyphen in like a Jupyter notebook instead of the underscore, it will give you error. So now in this slide, okay, so if you want to assign multiple values to variable, you can create all the variables at once and sequentially assign the value. Now, if you run this command, you will see that the values of the variables, chemistry, mathematics, and physics have been assigned accordingly. So you have to write physics, comma, chemistry, comma, mathematics is equal to 89, 90, 75. So it's mean that so you have to write different variables or multiple variables with the comma and the corresponding values. Okay, let's go back to the slides and let's learn about the basic data types. Next slide. Yep. So we have learned how to name the variables. Now we have to learn the basic data types. So the previously that we have named the variables and we write the values which are integers as a data type. So the basic data types are Boolean, which represents two values of logic, and are associated with the conditional statement. So the output values that you would get when you use a Boolean data type is true or false, and it is represented as a bool. The next data type is integer. It consists of set of all integers which are positive or negative whole numbers. It is represented by letters int, int. The next data type is complex, which contains a real and imaginary part. So any expression of form of plus ib is a complex, ib or ij, that is complex number. We call this as a complex data type. So these complex data numbers consist of all the complex numbers, and it is represented by the complex in a Python. Now, float data type. The float data type consists of all real numbers, which are floating point numbers. It is represented by float. String data type consists of all the strings and characters. The value that is enclosed between the quotes can be number, a special character, alphabet, anything. So mean that string data type can be written in the code with the quotations. So anything that is contained within the quotes is treated as a string data type. So it is represented by the letter str. So here I just representations mean how to code, how to write the representation inside the Python code. Okay, let's suppose if you write something like data type in a like the float. So here in the NumPy, yep. So this, yeah. If you write like in a quotations, so it's like a string. So if you change the numbers, okay, with the some like quotation or something inside the quotation, then you will see that it is a string. So why these are important when we will go for the NumPy, okay, when we create the arrays, then we have to define the data type. So what is the nature of the data that we are creating an array? So it's very important to define your data type. Either it is integer, float, bool, or string. Okay, let's go back to the slides. Yeah. Now, before we go ahead with data type operations, it is important to know the difference between statistically and dynamically typed language. So it's statistically typed language is the one where type of variable is known at the compile time, and you also have to declare the data type of the variables upfront. So examples of such programming languages are C, C++, and Java. So contrary to this, a dynamically typed language is the one where the data type need not to be declared upfront. The type of the variable is known only at the runtime. So whenever you declare a variable and you assign a value of it, the moment you run that specific line, the data type of the variable is known. Examples of such languages are Python, PHP, and so on. Python that we are using here is dynamically typed language. Okay, so this is only the difference that we should know. So what are the statistically and dynamically typed languages? Okay, please go to next slide. So let us go further and see how to identify the data type of an object. Now, to find the data type of an object, you will be using the function type and give the object as an input. Now, an object can be variable, can be any of the data structures, it can be array or anything. In this case, in particular, we are just going to look at how to find data type of variables. Now let us take a small example here. I have three variables here. The first is employee, underscore name, which is the name of the employee, and the value is RAM, enclosed between double quotes. As I told you, that something which is enclosed in the double quotes are string. So this data type is string. And the next is age of the employee, presented by the variable name age, the value for which is 55. The third variable is height, which is the height of the employee, whose value is 150.6. Now, if you want to check the data type, you can give the data type of the employee name. Now, employee name is string because it is enclosed between double quotes. If you give type of the age, age is an integer, and hence the output is integer. And if you give type of the height, which is floating point number, the data type is float. Okay, so let's write in the Jupyter notebook and see that their type. So there is a command syntax which is type. So using this type syntax, we can see what is the data type of the variable. So let's write employee underscore name. Okay, so now you have to write employee name, which should be enclosed by the quotations. Yeah. So now using the syntax type, we have to see what is data type of the variable. It is string. Why? Because it's enclosed by the quotations. Now write age is equal to 20, yes. Now we have to see it is integer. So the data type is integer. Okay, now height is equal to, yeah, that is float. So these are the data types. However, we did not declare what the data type should be because it is a dynamic. So this is the advantage of the Python, where you are not supposed to declare the data type. So because it will recognize automatically. So this is called dynamically programming language. Okay, let's go back to slides. So let's go to the next slide. So let's verify inside the Jupyter notebook. Okay, so let's suppose we say that the type is integer. If it is integer, it will be true, otherwise it will be false. So if we type like, okay, the type age is float, no. The type of employee name is string, yeah, if it's string, yes, it will be true. Okay, let's go back to the slides. Okay, next. So to summarize this part, we looked at some of the common naming conventions to name a variable in Python. We saw some of the basic data type related operations. One of that was to get data type of a variable. Then verify if a variable is of a certain data type. Okay, let's go to the next operations. Yeah. So in operators, in this part, we are gonna learn what an operator is and what an operand is. We will also look at different types of operators that is used in Python, and these are arithmetic, assignment, relational, logical, and bitwise work. We will also looking at precedence of operators. So this is something that you can do, okay, yourself, okay, after this part of the lecture, and then how to use them in an expression inside the coding. Yeah. So let us see what operators and operands are. Operator is a special symbol that will help you carrying out an assignment, operation, or some kind of computational. The nature of the computation can be arithmetic or logical. So now the value that operator operates on is called an operand. So let us talk a small example here to illustrate what an operator and operand is. In this case, the plus symbol that you see in this plus sign, that is an operator. The operator denotes addition. So you see two numbers before and after the operator. So 2 and 3 in this case are called operands. So let's go to the next. Okay, yeah, you are at Jupiter. Okay. So this is like difference, even now multiplication and division by the black slash. Yep, good. Okay, one more thing about there. So using the numpy. Okay, so we will see in the next slides, but here, so yeah. So let's go arithmetic operations that now we have seen addition, subtraction, and the next one, yeah, yeah, multiplication, okay, division, remainder, and exponent. For the exponent, we have two like asterisks, like in a multiplication that is 1, and in the exponent we have 2. So this may be this is very, let's suppose if you want say a square, so 2 square, so you have to write in this way the expression which is shown here for the exponent. Okay, let's go to the next. Oh, yeah, okay, you are going to the kitchen. Okay, for like the exponent, that you can see that how we can write the exponent, that is double asterisk sign. So let's suppose a exponent of b, then a double asterisk sign b. Yeah. So you can write two asterisk sign here. So this is will give you error. So you have to sign two asterisk sign 2 times. This is division. No, it is yeah. So this is no. Can you change the number? It's like that because it's too large. Okay. So let's go back to the slides. So this is a power b or a exponent b. Yeah. Okay, go to the next. So let us look at the hierarchy of operators. Now I have ordered the operators in the decreasing order of precedence. So the first is parenthesis. So the parenthesis is not really an operator, but anything that is enclosed within parentheses gets the upmost priority. So therefore, I have included parentheses, also an operation. Now, this is followed by exponential operations and then division, multiplication, and addition and subtraction are given the same precedence. So let us take an example here in this case. So so go to the Jupyter notebook, please. So we can write this expression and then how to work. So I have the expression. So I have a equal to 7 minus 2 into 27 by 3 square plus 4. A is equal to 7 minus 2 . So whatever you write without within the parentheses, so as we know that okay, in mathematics, whatever inside the parentheses in the expression, so the first we solve inside the parentheses. So same here actually. So if you write something inside the parentheses, it will solve that one. Okay, let's go to the slides. Okay, next slide. Yep. So the assignment operators. So let us look at assignment operators. So an assignment operator is used to assign a value to variable. So the first assignment operator that we are going to look into is equal to symbol. Okay, so here in the slide, you will see that is a multiplication is equal to symbol. And then we have another one that is divide is equal to. So you can change this assignment operator plus equal to, subtraction is equal to, and also your multiplication and division. So let's go to the Jupyter notebook and try to learn about these assignment operator. We have to declare two variables, a is equal to 10, b is equal to 5, and then we have to write the expression a plus equal to b. A plus sign equal is equal, yeah, b. Okay, now, okay, so you have to run this. Okay, so now you have to print. Okay, you can see, let's suppose, can you go to the third one expression, that is c equal to, yes, c equal to a plus is equal to, sorry, you have to write in parentheses. Yeah, c is equal to, no, a, inside the parentheses a plus equal to b. Yep. Now you can print the c. Yep. So why it is actually? The reason is that because we have already equal to, which we assigned to the c. So these two assignments operator cannot be used in the code. So this is why it gives the error. So now in the print, okay, you can go to, okay, you can comment it, that line, the c. Yeah. Okay, so now in the print, inside the print, no, you have written already print. Yeah. So in the print, okay, you have to write this expression a plus is equal to b. A plus is equal to b. Yeah. So why? Because this is something, it's like the error is like, because we have to do the assignment operators inside the print. So just you have to write and check the results. Okay, now only write print A. Print A.
Sorry, your voice is not clear.
Okay, I said only write print A. Print A. Yes. So what does it mean? So it means that, okay, so A plus B comes to the value A. So that A is going to be incremented by adding B. So A is going to be we are going to we are going to do increment in A by adding B. So this is the assignment operator. So similarly, A minus equal to B, A minus equal to B, yes. You have to, yes, now you run. So we did a decrement in A by factor B. So it's mean that this is like increment and decrements, that how you increment or decrement inside the variable. So we are using print to show the results, just to see the results. Okay, so it's not like an operation, it is just like to see the results, to check the results, to print the result. Okay, so now the division is well. So these are the assignment operator where you are assigned the values or increase the values or decrease the values, multiply or divide the values in another values by another factor. Okay, let's go back to the slides. Okay, so now let us see what rational or comparison operators are. A rational operator will test for numerical equality or an inequality between two operands. The value that a rational operator returns is Boolean in nature. Boolean is mean false or true, 0 or 1, which means it will basically return the true or false, means 0 or 1, like a logical. Now all the rational operators that we are going to look into have the same precedence, which means they all have the same priority. So let's suppose if we have assigned the value x is equal to 5, y is equal to 10 or something, then we have to see the symbols. Either x is greater than y or is equal to greater than or equal to the y or less than or equal to the y. So these are like rational or logical symbols. False. So this is the condition that is we call conditions, a loop or something that is if, else. Then if we say that A is greater than the B, then this next operation should be executed, otherwise it's jump to the next step. No. Okay. You have to illustrate. Yep. Now you write same line because it was correct only. When you get like the error in before the command, yes, it's correct. You also else colon to colon symbol. After the else, there are the colon symbol. Yep. Okay. Okay. Good. Let's suppose A now here this is like a condition that you have written like so. So there are like the importance of the operations in a different ways. So some are like in a looping or statement or conditions. So where we have to see the rational or logical operand. So and these operations have the importance over there in order to make a logic. Like here, Mohammed has made a logic, and he has assigned the two variables different numbers, 100 and 700. And if he says that if A is less than B, then this operation should be executed. That is, you have to print the pass, and if otherwise, it should be failed. So like that, okay, once it's a true condition, so if we say that A is less than B is the true, then it will print you are genius. And if it says that if it fails, then it will go to the next one. And the next one, that operation should be executed, that is you are not genius. Okay, so let's go back to the slides. Okay. So next slide. So these are the operations also, so which are called like logical OR, are the AND operations and the NOT operations. So a logical operator is used when the operands are conditional statement, like the Muhammad has done now. So the output for logical operators are Boolean also, like false and true. So strictly from the point of view of Python, logical operators are designed to work only with scalars and Boolean values. So if you want to compare two arrays, then logical operator cannot be used because these are the arrays. In arrays, there are the different numbers. So let's take our first logical operation, which is logical OR. It is denoted by the letters, or both letters in a lower case. So now let us take a small example here. I am returning the same value from x and y. Let's suppose x is 5 or y is 7. Now I give x is greater than y and enclose that within the parentheses followed by r, and then check for another condition, which is x less than y. I get an output that says true. Now why does it happen? So a logical OR is designed to give an output true when one of the statement is satisfied. In this case, x is greater than y. It is not satisfied, so it is a false. However, x less than y, that statement is satisfied. So this gives you an output which is true. So the inputs of the operator is basically false and true. So whenever you have a false and true operand, then the resultant is always true. So hence you are also getting an output which is true. The next is logical AND, which is represented by letters, and all letters again in lowercase. Let us take a small example here. I am taking so you are at Jupyter now. So now let's suppose you have to work
Or your voice is
operations.
not clear. Your voice is not clear.
Okay, I'm sorry, it's like some of the problem here. So is it hearable now?
Yes, even in US there is a problem of internet.
Yeah, I am on holidays. I told you that. So here, okay, maybe yeah, it's like Table Island, which is far from the city. So might be something is a problem. So I hope that you can hear me now.
Yes, I can.
Okay, let's work on the logical R now in Jupyter notebook. Okay, so now you have the two variables, X and Y are A and B. So now you can print inside the parentheses as shown in the slides. Okay, and then again inside the parentheses, again parentheses, yeah, inside the parentheses here, yes, up, yes. You can type the parentheses. Why? Okay, so one is true and other is false. So the false is X greater than Y. The true is X, Y. So this statement is true. Why? Because this is our condition. Okay. One thing I want you to write this all the expressions inside the parentheses. Enclose this all expression inside the parentheses. Yeah. And can you change the and with or? It should be true. Yes. So this is just like a logic, the and or logic. And also there is logic not, that you can say that not. Okay, so
Can you give them one example that how they can practically use in their engineering studies or simulation studies these logical operators?
yes. So these logical operators, let's suppose in the process, we can say that if process one, okay, is gonna be successful, okay, and the other one is not successful, we don't care. Other one, okay, then the process should go on. And the condition is that the two processes are very important, and these two processes should be accomplished. Then the other process, the next process should be executed. So to put an end condition. Okay.
I can give them an example. For example, if this you are an engineer and you have to do like 2,000 simulation runs, you are
Mhm.
we are here talking about for the Python language. We are not doing for 100 or 200 values or one or two
Mhm.
values. We are doing here
Mhm.
for thousands of values. We are
Mhm.
we are dealing here with, for the data science. And in
Yeah.
data science, we don't deal with one or two or five numbers or 10 numbers. We are talking about millions of numbers or thousands, at least thousands of numbers.
Yeah.
And we manage our data. So for
Mhm.
example, you have to run a simulation file, which is probably you have to run like 50,000 times in your
Okay.
laptop. And if you start doing it by on your own and making a
Mhm.
decision, okay, it is true, it is false, it is true, it is false, probably you will take a month to solve those 2,000 to 50,000 runs to do that.
Yeah.
But if you set up this kind of operation as you see X and Y and X less than Y or X plus, you already connected with your simulators. This
Yeah.
give them the the return to the simulator, and you can sleep at your home, and this software Python will connect with the simulator, and simulator will take the input from your this algorithm which you just wrote it, and
Mhm.
you just your job will be easier, which for the 50,000 runs. Otherwise you have to sit down, accept true, it is true, this run is correct, this kind of run is not correct, this is correct. So for example, 50,000 times you cannot just sit on the computer and do it. So that's here comes the power of Python or these programming languages, where you can use these X and Y in these logical variables and connect them with your software simulators, whatever you are doing. And for the larger runs, let's say 10,000 runs or 5,000 runs, you can set up your algorithm, and it makes your job pretty easier and very nicer. And in the end, you get the very nice output just by doing nothing. Just what was your success here? Was you just write the algorithm which connected with the simulator and so on. I think that was my explanation.
Yes. Yeah. It's very nice and nice example. Actually, the language is based on the logic. Okay, a programmer should be like the should be like intelligent logically. So he should when he's gonna be code anything, so he always think about the logics. Okay, so the logics. Okay, these are some of the operands, very basic operands that I'm telling you now, that you can include in your program. Okay, so that you can make it very like the understandable. Okay, for you, even though for the machines. So these are like the logics that you can include in it. Okay, even let's suppose there is an operation and there is a result of the operation inside the coding, and the operation you say its operation is like a zero, result is zero, then it should be stopped. Otherwise, it should continue. So this kind of the logics you are using there, or you are using like some statements or like a while loop or while loop. This is something another story. So there you will need these kind of the logics. So we use these kind of the logics over there actually.
So
So any programming language.
asked me before that, okay, Python, you're doing 1 plus 1. So why should I
Mhm.
do this 1 plus 1? I don't need this 1 plus. I can use my calculator to do this 1 plus 1. So the
Good.
answer to that question is that we don't deal with 1 or 2 numbers. We deal in data science with thousands or millions of numbers. And there
Good.
you cannot go by hand or use your calculator for million of number, or let's say 100,000 numbers. There you need a program that can do it for you. And you need their
Exactly.
to solve that for you.
Yeah, this is something. But whenever you start any language or something, you always start with a very basic. That you because this is something that you can understand now, which is understandable to you. Before going to in a complex type of things like suppose big data, where you are not sure what is going behind the black box. So when you know that their basics, then you can understand the complexity. So when you start with something, in order to get familiar with the software IG, then you need to go with the very basic things. Okay, so now let's go to the list.
And here comes the roll of list where you can, write down, let's say,
Yeah,
2000 numbers.
yeah. So what is mean by list? How to create a list and the indexing, and because inside the list you have to find their indexing number. So also the assessing the components of the list actually. So this in this part we will see that how to create a list also. So go to the next one. So here that let's see that how to create a list. So we will create a list of the employee ID and also for the employee name, and also we will create a variable that contains the number of the employees. Okay, so they allow the employee's name. Let's suppose we have some employee's name and we also create their IDs, and then we know that how many employees, let's suppose 4 employees. And I'm creating a list called ID which has set of the values 1, 2, 3, 4 within inside the square brackets separated by commas. We will also create an employee underscore name as a list, so which consists of values, let's suppose Ram, Printi, Satish, and John, which is separated by commas, so that it should be correspond to the IDs. And also we will create a variable called number underscore employee, which has a value of the number of the employees. So let's go to the next. So now let us see how to create an employee list using this employee ID, employee name, and also the number of the employees. So I will create a list employee underscore list. which has values ID, employees, underscore name, and also the number of the employees inside the square bracket. Let us see how to view the list. We will use the command print of the employee underscore list. It gives all the list which has the values, the ID values, and also the employee names, and also the number of the employees underscore under the employee underscore list. Okay, you can write these things inside the Jupyter in order to feel this how to create a list. Yeah, now you have to print that employee list because inside the employee list you have included ID, employee names, and number of the employees. Yeah, because here you didn't, okay, after the ID, yeah, now you can print this employee list. So this is the list. The advantage of creating the list are you can use this list to create the table as well. Okay, of the employees. Okay, whatever you want. Okay, and also you can create when you read the data. So whatever the variables or headers inside the data you have, you can create the list. So then you can use that list inside the program instead of calling that table or the data again and again. So you can create a specific list that you can work on it actually. And you can create a lot of the lists as well so that you can code in a very simple way calling the specific particular list. So this is only the advantage of creating the list.
Yes. And when you go for the real work on this one, actually you store this kind of data in the databases. And as you know, we have two kinds of database, structured and unstructured database. This is kind of a structured database. So what this program Python will do, you will call your data from that database or in Microsoft Excel to here, it will do the processing and send it back, the outcome back to your software to do the further, take the further actions. That's how it works.
Yep. Okay, let's go back. Okay, now there is another part of this lecture, it is sets. So you can go, okay, next, 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 next. Yeah, next. So that sets, yep, next. Yeah, so we are very familiar about the sets, okay, that we are usually study like in a 7th class or like something. So we just use how to use the sets inside the Python and how we operate them. So how to create the sets, how to modify the components inside the set, and what are the, let's suppose, basic operations of the set, like a union, intersection, difference, symmetric difference. So we will do this thing. So go to the next slide. Yep. And we are very familiar with about the sets, okay, so no need to explain the definitions, but we know that we create the set, or we write the sets into the curly braces. So this something like in a Python, we use these curly braces in order to declare the set. Okay, go to the next slide. Yeah, this. So like here we have the creates like the set of the employees name, and then inside the curly braces, and then we print the set, and it will come like this way. So this is like the how we declare the set inside the curly braces instead of the braces. So go to the next. So now what are the, like suppose the operation, or like we can say like how to modify the sets. So let's suppose if I have the set name and I want to include another name inside the set. Let's suppose I have to include another name inside the set, then I can add the name of the object or the name of the employee that has I did already. So simply like how to modify them, like adding the other names, or to maybe subtracting the names or subtracting the object that you want. So you can do like in a set. And if you want to like this like discarding, that is command, this is discard. Just go to the Jupyter notebook. Okay, we can create this. Yeah, this is an input. So we can create. Uh, can you change like a braces with curly braces? Curly braces. Yeah, curly braces. This is curly braces. Mohammed, please change the parentheses with curly braces. So we, yeah, curly braces. Yes, because we write the set inside the curly braces. Okay, remove this. Yeah. exactly. Now print the employee name. Yeah. Okay, now you want to discard this Muhammad, so simply that is command declare discard. So discard and then write the name that you want to discard. So instead of the 8, okay, you can discard that name. Discard. So what do you want to discard? Let's suppose. Okay, so here we have discarded that. Okay, it's mean that how to modify the set. So where this set is actually used. So keep in mind in the pandas, which is based on the data frames and dictionaries. So these are the dictionaries actually. So employee name is a dictionary where you have this set of the members. So you have to play with the dictionaries, which is read by the pandas. Let's suppose you have the big data and you read from the pandas, and now you have to modify this data. And we will see in the next lecture, okay, in panda frames, that how can we modify our define. So let's go back to the slides. So next slide. Okay, we have done this. Okay, this is like a clear, okay, so which removes all the elements from the existing set. So you can clear it. So let's suppose we want to clear that employee name set. We said clear. Okay, so this is command which is clear. So when you clear it, so the set will be clear. So okay, go to the next. So now let's go with some operations. So like a union, okay, and intersection, differences, addition. So you can do it. Let's suppose there are the two sets. Okay, junior data scientist, a data scientist, and some members. Let's suppose junior data scientist says member R, Python, Tableau. So data scientist has a member R, Python, Scala, Java, Tableau. So we have to see, okay, go to the next slide. So this is like a union operation. If we uh, do like the union of the A over the B, then we say that this is the function that is union. That we say we write like a set A, that is A dot union of which that is, let's suppose, B. So then we just print like the union. That we say, let's suppose union is equal to the set A dot union of the set B. So this is the command that is union. Go to the next. Simply there is intersection. Okay, so that is the intersection that we have. Okay, so command that is intersection. If we have operate intersection of A over the B, then intersection A dot intersection our B, or if we want intersection of B over A, then B dot intersection of A. So this is like a command of intersection that you can use it. Okay, go to next. So the difference, okay, this is command of the difference. So similarly, if you want to make the difference of the set A from the B or B from the A, so you can write it. Okay, go to next. So like the symmetric difference, okay, which returns the element not common to both sets. So if we have like the A symmetric difference over the B or B a symmetric difference of the A, so that we use a command that is symmetric difference. Okay, go to next. Okay, so this is what we have learned, like the adding, discarding the member from the set, clear the set, and some operations. Okay, let's go to the Jupyter notebook and try to work on these sets and these operations. The reason to include this part actually, because just to get familiar with using the IDE, and no doubt you will see when you will go in a practice in a deep, especially in a pandas where you're reading the data, you have to work on this kind of the sets. Okay, so now we have to define the set A, set B, and then we have to make the operations union, intersection, difference, symmetric difference. So let's suppose A is equal to whatever you want.
Sorry, then what is the next step?
Sir, I think your mic is mute.
Okay, can you hear me now?
Yes, sir.
Okay, I'm sorry, it's something like. Okay, so we have like we have seen like a union and intersection. So if we have to, like, suppose another operation that you want, that you can, so let's suppose the difference, that is difference, okay, and instead of, okay, so Muhammad is right here, the full difference, left dot difference. So you can write also you can apply the operation, the difference operation that you want. So let's suppose set that is lab dot difference inside the parentheses, that is set that is pt, and then there is a symmetric difference also, and then you apply that command, that is symmetric difference. So I'm writing the commands in the chat box.
Dr. Mumtaz, let's take a break for 5 minutes so everyone gets refreshed, and we go, because the next
Yeah,
one, NumPy and Pandas, bit advanced than this one.
yeah, so like that. Okay, so you can just like some operations on the sets in these lectures. Okay, sure.
Okay, so now we go on the break. We come back around 6:15 again back for the next couple of like 15 to 20 minutes more, and then we will finish this workshop. So 6:15 will come back till you get fresh, have some coffee or tea or something. So because we have two more libraries to talk about, which is the NumPy and the Pandas, which are the most important in the Python. So we will be back like 6:15 for that.
So it can be used for numerical computations. So if you wanted to calculate a sum or mean or median, so you can use the NumPy package. So there are different packages also available. So you have Pandas, SciPy, and all. NumPy is basically for numerical computations. And the arrays, where a lot of the arrays are included, is a multidimensional container of objects which are of the same type and size. So it supports n-dimensional array objects. It can be used for processing the multidimensional data, as well it also supports different data types. So let's go to the next one. So using NumPy, we can perform some of the operations. So the first operation is, so you can calculate mathematical and logical operations on arrays. So if we wanted to compare two arrays, we can do that. So if, let's suppose in the previous slide, we were just comparing one variable or two variables. Now here we are comparing the arrays which contains more than one variable in thousands. So it can be used for the Fourier transforms as well, linear algebra operations. If you wanted to find a rank or determinant to solve the system of equations, so we can using the NumPy package, and NumPy, it is also used for the random number generation tool. So let's go to the next slides to see how to create an array. So first we will see how to create an array. Array is basically an ordered collection of elements of the data types. So the basic syntax, if you have to specify the package name. So which is a NumPy is a package dot array, and inside the parentheses you have to specify the object. So first we need to import the NumPy package every time when you run the code, like import NumPy. So I'm going to import NumPy as an NP because it is easy for me to use in the program. So it is basically analyzed to the package np.array. Inside the parentheses, I'm giving the sets of values. So I'm giving 2, 3, 4, and 5, and I am sorting it in a variable called x. When you give parent type of x is basically returns an object of the data type. Here we have declared it as an array. It has returns a NumPy ND array. So NumPy n-dimensional array. So when you give print of x, so you have 2, 3, 5, and so on. So you can write this into the Jupyter notebook to get familiar to how to import the NumPy. So we should go to the Jupyter notebook now. So first we have to import the package that is NumPy. So without importing the package, you cannot work on the NumPy. So NumPy is a very strong library for the numerical computation. So yes, okay, you can run it. So we can, yeah. So now we have imported the NumPy. So if it gives you error, it means that you need to install the NumPy library. So here already installed. So as we assume, because this is from Spider, so which where all the libraries are already installed by the Anaconda.
Yeah, that's the reason we moved from the Spider to Jupyter, because Jupyter has already all of them.
Yes, cool. So now we have to generate an array. So let's suppose x is equal to the np.array. Yeah, inside the parentheses. No, first we have the parentheses, then the braces. Yeah, inside the parentheses, the braces. Yes. So this is the way to generate any array. And now let's suppose there is a data type we did not include the data type.
What
so it is like, so let's suppose if we say that data type is equal to integer. So after that, so first we have to go with it, then we will include the data type. So now you can print the X, and then you have to see what is type of X. Yeah. So the type is an ND array. So now can you go to the second one, X is equal to NP array, okay, and then after the braces, not parentheses, after the braces, yeah, here, no, after the parentheses, not before, yes, after, can you go? Okay, so here you can also include the different like the data type, okay, so which also see that how it prints. Let's suppose here I'm also printing. So what before it was like the integer, so that was like the integer, now it's float. So it's like let's suppose if I'm writing here, so it's like a float because 2 points, okay, these are the zeros, so you have to see if it's integer, then it will not show you after the zeros. So it means that you can create the array, so any type of the data. So let's suppose integer data type, float, whatever string, so you can create it. So this is like how to generate like the array. And then let's suppose if you go with another one, and you can include any categorical entities inside the array, you can. So let's suppose if we have this, instead of the 4, we say that it is M. So like here, so it says that M, obviously it's a string. So it says that because I include the data type is integer, so it gives the error because I included the string. So if I remove the data type, so that it should create it automatically. So now here it's like. So this is the why that we include the data type, that it shows that what type of the array is. So before I included the data type is integer, I included the M, which is string, so it gives you an error. So in the array, so you need to create array, and then you have to see that what data type it should be. Either it should be float, integer, string, or something else. So let's go back to the slides. Okay, so go to the next. So this is some, like, I included the operations. Like if you want to create an array of a different shape, and it create of the ones actually. So you can create in such a way that, okay, this is like the library which is already included in a NumPy of creating the ones. So you can create the matrix, you can create the zeros, matrix of the zeros. So you can have to tell what the shape of the matrix should be. Either it should be 3 by 4, 2 by 4, and what of the matrix should be. It should be integer, it should be float, or string. So you can create these ones and zeros. Go to next. So this is like a zeros. So giving these two examples, just letting you know that what the operations are there actually in NumPy. So NumPy is an ocean. You can find millions of mathematics and statistical uh, tools over there. So just you have to call them. So like importing the NumPy, and then whatever you want to uh, find the operations. Let's suppose NumPy dot determinant, okay, NumPy dot cross sections, NumPy dot algebraic operations, whatever you want. There are lots of operations. So just you have to call them using the NumPy. So here just I'm including two basic examples, just letting you know how to call them. Okay, go to the next. So here, what are the advantages? So main advantages of the NumPy, it supports vectorization. Okay, so mean that operations are going by vector. And so second advantage of NumPy is, just a minute. Yeah, so the second operation of the NumPy, so that is array operations. They are carried out in C in the backend, and then they are executed in Python. Because of the C at the backend, so it's so faster comparing to the Matlab. So NumPy performs faster than the list. So why I included the list? Because like in the Matlab, we always use the list, but here we use the array. And what are the reasons why the array in a Python is faster than Matlab? That is a C, which is C programming, which is at the backend of the Python. That why is a faster in computation than Matlab. Okay, please go to the next. Okay, let's go to the Pandas. Okay, so after the NumPy, the Panda is very uh, important tool for the data science. So there are some advantages of the Pandas. Go to the next slide. Let's discuss about the advantages of the Pandas. So, and the Pandas library is also available. So it has also a lot of the tools that you can use over there, especially for the data analyzing, okay, data reading, data manipulation, data cleaning, and other things. So to introduce you to the Pandas library, it provides high performance, easy to use data structures and analysis tools for the Python programming language. It is an open source Python library which provides high performance data manipulation and analysis tool using its powerful data structures. And it is also considered one of the powerful data structures when compared with other data structures because of its performance and data manipulation techniques. So it is available in Pandas. When you search for the Pandas library, it is very easy to find over there, and you will see that a lot of the tools to manipulate the data. So here is a description of about the data frame. Because when you read the data using a Panda, it is a data frame. So data frame consists of two dimensions. The first dimension is the row, and the second dimension is a column. That is what we mean by two-dimensional and size mutable. And whenever we say data frame is collection of data in a tabular fashion. And the data will be arranged in rows and columns, where we say each row represents a sample or record, and each column represents a variable. The variable in the sense of the properties that are associated with each sample. The second point is that potentially heterogeneous tabular data structure with label axis. Okay.
Excuse me, because actually we are running out of time. So
Yeah, go to the next slide. So we have to see that, okay, we just
So
see
we-
how to.
yeah, we want to finish it at 6:45, and you're probably 10.
Yeah,
So maybe
okay.
half 10.
Yeah, go to the next slide. Yeah, so here how to import the Panda actually, like we imported the NumPy. Okay, go to the next. Yes. So here now we are reading the data. Okay, using the pandas, and then we manipulate the data. So just go to the Jupyter notebook, and we have to import the panda as a PD, and then we have to read the one file, that is CSV file. Okay, and then we have to manipulate the data exactly. Okay, so this is the file that we have to read using the pandas. So first we have to import the pandas as a PD.
It has around 1437 values,
Mhm.
rows, I mean, and it
Yeah.
has 4, 5, 6, 7, 8, 9, 10 columns.
Okay. Yeah. So import pandas as PD.
P.
D. Yeah. Okay, now go to the, okay, let's suppose we have to read the data which is related to the car. Cars underscore data pd dot read underscore csv and file name. Sorry, Mohammed, this button is not working. pd.read underscore CSV.
So it's available in C drive. I can show you the location.
Okay, so you just write the command that is written in the slide.
Okay, let me do it.
Yep. Okay. So run these both.
Run them. Okay.
Yep.
Sorry, you didn't.
Mm-hmm.
The code is running, I think.
Yeah. Okay. So here we are now. We have it. You can print the car list. You can print the table that is you have read now.
Print
Car list, car underscore list. Okay. So here we have read the table actually. So this is the way that we can read. So letting you know that, so if you want to involve in a data science, okay, so you have to go with Pandas. It's a very basic library, very easy to use, okay, enriched with a lot of the tools that you can manipulate your data. Okay, so now we don't have much time, okay, so I'm not going to detail that how can we manipulate the data actually, but I have included in the slides that you can go follow it. Okay, just okay, basic thing is that, so let's suppose if you want to just like the columns, okay, if you want to just print the columns, so just write cars underscore list dot columns. Okay, so car underscore list dot columns. Car underscore list. The name of the variable that you are reading the table, that is car underscore list dot columns. Your car underscore list. Okay, so these are the columns names that you have, like price, age, kilometer, fuel type, whatever you have. So simply you have like headers. It means that we are reading the headers now. So you can do many other operations on the table that you have read. So let's suppose you have said that size. What is size of the table? Okay, so what are the entries of the table? You can say that the variable that is car underscore list dot size. So what is the shape? So what is the shape? It means that how many rows and column. So like a dot shape, so the variable that you are reading. So simply that you can see that how much memories they have actually. You can use a memory or something else. So different operations you can perform now on the let's suppose you can just cut the table. You say that okay, you only need the 6 rows. Then you have just like a 6 rows. Okay, or 6 headers. You can use the 6 headers also. So it means you have different type of the operation that you can perform it. So this is very important to explore the pandas. And they are very like when you go to the explore the pandas on the official site of the library, you will find a lot of the examples and to get familiar with it, basic. Okay, so then you will see that how to visualize the data. So second is the visualization. The visualization is very important in a pictorial way. So because when you put your data in a pictorial way, which is very understandable, which is better than 1,000 words. So, and now you have to be very like the artist that how to present your data in such a way which is understandable, which tells the story to the people actually. So there are the many tools to visualize it. So I want to give you some insight, some tools of the visualization that you have to go through in it. So can you go one slide set of visualization? No, the first where there are some of the tools. Yeah, the next one. Yeah, these are the tools actually. Matlab, Panda visualization, Seaborn, Plot, and Plotly. So these are like the open source tools to visualize your data. So and this is like of course this is another the high stage that is machine learning, scikit-learn. You can explore that library as well. And then the tools, remember the NumPy, Pandas, okay, and your visualization tools, Matplotlib, Panda visualization, Seaborn, ggplot, Plotly, and this Sky-learn for the scikit-learn for your the machine learning, and the TensorFlow for your deep learning. So these tools are very important for the data science. So I'm again very sorry, okay, for like the problems of with my voice and taking your more time. So thank you very much for your tolerance.
All right. If there's any more question, if there's no question, we'll wrap this up. So if anyone has
Okay.
any questions.
I just have one comment. Can you please issue the certificate to the participants because they can add this up in their CV. So we will
Yeah,
send
yeah, sure.
certificates, and you just sign it up so we can send to the participants later on.
Sure. Anytime.
Thank you.
Most welcome.
Okay, there seems to not be any more questions. So that was all for today. Again, thank you all for participating, and thank you for Dr. Muhammad and especially Dr. Mumtaz for taking the time and effort to be here today. And we hope we all found this interesting and useful, and we hope to see you in the future. Thank you.
Thank you.
Thank you. And I just have one comment. This was
Yeah.
the beginning of Python, not the end of Python. So
No, this is very basic. Very
yeah,
basic.
so this is what I wanted to say. This was the beginning of Python. So don't take it as
Yeah.
this is end of it. No, this is just the beginning. So end is very deep, like a sea. Okay. So thank you so much for all being here with us.
Thanks.
Thank you so much.